Okay, as you can see, we're going to do a practice problem for a t-test. And I'm going to read the scenario first, and we'll talk about why it's a t-test and why it's a certain type of t-test. So a study was conducted to determine whether a series of health talks could impact the knowledge of participants who attended the health talks. The following are health knowledge measurements taken on 15 individuals before and after the series of health talks. And you can see our data here. We have our participants. There's 15 of them. And then we have their post-test scores. So we have a post-test health knowledge score for each of the 15 participants. And we have a pre-test health knowledge score for each of the participants. And so the question asks us to determine whether there is a difference between pre and post health knowledge in these 15 individuals. So the first thing you have to ask yourself is, what's our key word here? And our key word is difference. And difference helps to key us in on either a t-test or an ANOVA, because those help us test the differences in the means of groups. And so here we see we're looking for a difference between pre and post. So there are two situations here, pre and post. And for two situations, we use a t-test. If you have more than two situations, you have to use an ANOVA. So we've established with difference and two means that we're comparing to see the difference, we're going to do a t-test. Now we have to decide what type of t-test are we going to do. So you can go back and look at your data, and you notice that we have a measure for each participant for post-test, but we also have a pre-test measure for each participant. So for each participant, we have two measures. So we're going to do a paired samples t-test because we have paired data for each participant. So we've established that we're doing a t-test and we're doing a paired samples t-test. So let's start with our 9 steps, and then we'll get into SPSS in just a bit. So if we look at our independent variable, if I can spell correctly, you go back to our scenario. What was the change, or what was happening in this particular scenario? And it was the series of health talks. We're trying to see if health knowledge before and after the health talks changed. Okay, so our independent variable is the series of health talks, and that would be considered nominal. And our dependent variable, if we go back to our scenario, is what is being measured. So our health knowledge is being measured. We have post-health knowledge and we have pre-health knowledge. So our dependent variable is going to be health knowledge. And if we look at the scores that we're seeing, they look similar to what we would think of as percents, which is literally ratio scale data, if you know anything about how percents and ratios align with each other. So we have our data where we have our independent variable, our dependent variable, and we've labeled the scale of measure. So now we're ready to start our assumptions. And so we're going to go to the handout that you've already probably read for t-test analysis. And on it, you'll find the assumptions for the different t-tests. The first one is the independent samples t-test. So you want to make sure you get the correct set of assumptions. So we're going to copy this. I've got to copy all of it. This mouse is a little sensitive. And we'll go back here and we're going to paste it. And let's do a little bit of fix our format. Okay, so the very first one is the dependent variable must be interval or ratio scale. So all you have to do is go right back up to step number 1, look at your dependent variable because you've already labeled its scale of measure, and you'll see that it's ratio. So we can say that this mouse is really getting me. We considered the variable or data and the scale on which it was measured and it was measured on ratio. So we are good with that particular assumption. The next one is the sample means for each group. So that would be pre and post within the independent variable must be normally distributed. So now we need to enter our data in SPSS so that we can run a histogram. So if we go back to our data, we can copy and paste. Okay, so we're going to copy our post test. And we're going to come over here and paste it in SPSS. And then we're going to copy our pre-test. And, oops, yeah, let's undo that. Copy our pre-test, and we're going to paste it over here. Okay, now before we do a lot in SPSS, let's go to variable view and let's label our variables so we don't get confused. So we did post-test first, and then we did pre-test. We don't have any decimals, so I'm going to put that down to 0. I like to label mine because when you do a printout in SPSS, if you label, it'll provide you those labels on the printout. And what we know is that these are ratio scale. That's our health knowledge measures. So if we go back to data view, you'll notice now that our variables are labeled. So we initially came to SPSS to run a histogram to see if each of these sets of data were normally distributed. So we're going to go to graphs, down to legacy dialogues, and all the way down to the bottom to histogram. And we'll just do post-test first. You're going to move it over to the variable side, click display normal curve, and click OK. And it will come up, and before I even look at that, I go ahead and run my next one so I don't get bogged down in the details there. And we're going to push this back over, get pre-test and put it over. Our normal display normal curve is still clicked, and we're going to click OK. Okay, and so now if we look at this, we have our post-test scores on health knowledge, and we have our pre-test scores on health knowledge. And if you notice here, it's a little bit skewed to the left, and this one's a little bit skewed to the right. But if you recall, and I can show you on the assumptions, if you recall, it says to check this assumption, one must run a histogram using SPSS. The data should appear to be normally distributed with moderate skewness. It is important to note that a t-test analysis is robust against moderate violations of this assumption. Therefore, the data may be moderately skewed and still allow for calculation of an accurate t-test. So even though our data is just a little bit skewed, just notice it's just one person here and one person here that's making this difference, and then the same down here. It's just one person. So it's just moderately skewed. If it was all the way over here, and this one all the way over here, we would have some major issues. But these are just moderate, so we're going to say that we're okay on this particular assumption. So we're going to say that we... Well, if I can learn how to work Dr. Slining's mouse, we would do much better. Here we go. Okay, so we ran a histogram using SPSS. And the data appeared to be normally distributed with moderate skewness. So we're good here. Yes. I'm going to take this away. If it'll let me. There we go. Okay. So now we're on our final assumption. The differences between the paired scores must be independent of each other. And it says to check this assumption, you should consider the data. Each paired score should represent a different individual. So if we go back to our data, this is where it's really nice to have this column that says participant. Because with this column, we know that participant number 1 is different than participant number 2. So our paired scores for participant number 1 are independent of our paired scores of participant number 2 because participants 1 and 2 are different individuals. So we are okay on that assumption as well. So we considered the data. Each paired score represented a different individual in theory and in actuality. And so yes. So we have passed all of our assumptions for our paired samples t-test, and now we're ready to write our hypothesis. So you'll recall that we have a null hypothesis, which usually carries the negative. It's what we're testing statistically, so it's what SPSS will test for us. And we're going to say there will be no difference, because remember t-test tests for a difference in means. We're testing for a difference in health knowledge after completing a series of health talks when compared to health knowledge prior to completing a series of health talks. So what this is telling us is we're looking for a difference in post and pre for health knowledge. Okay, so now we're going to do our research, or our alternative, which is the one we really want to find out as researchers. It's not what's being tested statistically, but what we want to find out. So it usually has the positive connotation. So there will be a difference in health knowledge after completing a series of health talks when compared to health, I need to go back and add knowledge, prior to completing a series of health talks. Go back up here and add knowledge. All right, so that's what we're going to be testing. We've already established for step number 4 with test statistic that we're going to be doing a paired samples t-test. Sometimes you'll hear it referred to as a dependent samples t-test. Same thing, just people use different terminology. The book that we're using uses paired samples t-test, so we'll go with that. The decision rule, you guys are very accustomed to drawing this at this point. You can probably draw it in your sleep. So you'll want to add that here. Remember that you have your axis where you have a bell-shaped curve, a normal distribution, and you have the two tails that show the significance levels at 0.05. In the middle of that curve is the fail to reject region, and on the two tails is the rejection region. And it's always important, we're always going to reiterate that you have to set this decision rule before you run the analysis, because you want to make sure you set your rule and know what you're going to be comparing to before you look at your answer. It just kind of helps to build some ethics into research. So now we're ready to calculate the test statistics. So we're going to go back over to our data. And just so you know, in SPSS, you can run the analysis from your data or from the output. Either place you can run your analysis. I like to go back to my data just to make sure I'm running it on the data that I want to run my analysis on. So we're going to go down to Analyze, Compare Means, and we're doing a paired samples t-test. Again, this is sometimes called a dependent samples t-test. And you're going to enter your pairs. So you're going to move post over and pre over. And students a lot of times will ask, does it matter what order you enter it in? It really doesn't. You're going to get the same t value. You might get a different positive or negative t value, but that just depends on what you entered first or second. The value and the p-value is still going to be the same. So you're fine, and if you want to enter pre first and then post, that's perfectly okay. All right, so now we've got our data. And to go over it a little bit, here's our descriptives for the sample. You see the mean for the post-test was 83.27. We had 15 individuals, and the standard deviation was around 10. The mean for the post-test was 65.73. Again, we had 15 individuals that were measured, and we had a standard deviation of 9.239. You also get this paired samples correlation. You don't have to worry about this particular part of the output at this level of research that we're doing, statistics that we're doing. And then here's where you get the majority of the information that you need. You can see the difference in the post-test to the pre-test was 17.533. And if you want to just check and make sure SPSS did it correctly, you could actually test it out, and that would be the difference there. Here's the standard deviation for the mean difference. And then if you go all the way over here, you'll find your t-value, your degrees of freedom, and your p-value. Remember, in SPSS, they do not use the term p, they use significance level. So we're going to go back over here, and we're going to say our t with our degrees of freedom of 14 is equal to 8.101. And the t should be lowercase. There we go. All right. Our p-value, if you recall, it was over here. You see it's 0.00. We know there is always a chance that chance is working. So we know our p-value is less than 0.001, but we don't know exactly what it is. SPSS only shows us 3 places after the decimal point, so there's other numbers over here, we just can't see them and we don't know what they are. So what we can say, to the best of our knowledge, is that our p is less than 0.001, which we know that is less than 0.05. And so if you go back up to your decision rule, and you know that your p is over here in the tails, and we know because of that that we're going to reject the null hypothesis. And so when we reject the null hypothesis, we say, we just don't say it out loud, we want this one. And so our conclusion is there may, if we can get it to type, may be a difference in health knowledge after completing a series of health talks when compared to health knowledge prior to completing a series of health talks. And you always want to include your statistics to substantiate this conclusion. If you read this to Dr. Sleining or myself, we would say, so why do you think there's a difference? And so these statistics that we put in here help us to know why there is a difference. So we've got our degrees of freedom, and we're just pulling this straight from right here where we've entered it in step 6, is equal to 8.101. And our p-values, you can go back up to step 7, so all of our information is already here, is less than 0.001. We're going to close out our brackets. So we put it in just statement terms, and then we provide the statistics to substantiate why we think there may be a difference. And we always cushion it with may, because of this right here. There's always a chance that this might not be correct. Okay, we could have made a type 1 error. Okay, if we rejected the null, there's always a possibility of making a type 1 error. And we never know that we did or did not, so we always have to say may. So if we do, based on the book, if you've been reading in your book and following along, it provides a little bit more of a thorough and comprehensive discussion of our findings. So we would say a paired samples t-test was calculated to compare the mean pre-health, I'm used to writing healthy all the time, health knowledge score to the mean post-health knowledge score. The mean on the pre-test was 65.73, and remember it's over here in your descriptives box. There's 65.73. And the standard deviation was 9.239. And again, it's right here. Okay. And the mean on the post-test was, and we'll go back over here, it's 83.27 with a standard deviation of 10.333. A significant, we rejected the null. We think there may be a difference, so we're going to say that we think this is significant, statistically significant. A significant increase. How did we know there was an increase? If you look at your pre-mean, 65, your post-mean, 83. So we had an increase from pre to post was found. And we say significant, so we have to have statistics to back up why we think it's significant. So we put in our T once again. Close out your bracket, and then you're done. So now we have all of our 9 steps, and you have your data. Remember, most of your data came from here and here. So we think, based on this data, that our series of health talks may have helped improve their health knowledge, is what our conclusion